Alright, so we are on our second week of online, 23rd, and we talked about a little bit about IP addressing, 4 primarily, mentioned a couple things for 6. I'll talk a little bit about that. I have this slide repeated coming up. But first, this is a little review from the other day, how our networks work. We have this, you might remember this was one of the slides in from the previous week, or from the previous days, last week. And so we talked about these different networks that we have stemming off here. I think we have 12. And each of them has a router, each of them has a switch, and we're going to adapt our labs to match these. So the students have them all configured with some addressing that's in the lab information. The lab info. And I talked a little bit about, we have in this router we talked about the parts of the network. I actually have up here a route that says if it's any of these, send it down in. If it's any of these, then it goes this way. Actually, this way is a default route, and then we have a static route coming back down in. Each of these routers have a, in fact, let's just use another color. So let's say a red. You don't know, you default out. You don't know, you default out. Same thing with the switch. If it has information it needs to send and it doesn't have MAC addresses, so to speak, you default to this MAC address, default out. And then we use static addresses coming back down in, actually pointing. Like this device here has a static address in there pointing to each of these networks, to this much right here. Pointing to that much right there. We're gonna try some lab work on that on in our groups on Thursday. Let's keep moving. You're saying yes, Mr. Dirksen. Keep. So we talked all about IP addressing. This gets a little crazy, but we talked about basics, and then we talked a lot about segments. So in the example up here, coming off the router, you can think of this as a segment, a certain part of the network in which we are using a address, okay, right? This part, it's a /24, and that's 8 bits, 8 bits, 8 bits. And so that is the network part of the address. And so this part, let's use another color for that. Yeah, let's go yellow. This part is the host, or sometimes referred to as the interface. Prefix bits, 24, or we could list the mask. If we listed a mask, that would be 255.255.255.0. So if you convert that to ones, that would be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So going back, when the router looks at its routing table, it takes the mask, okay, and in our scenario over here, these would be all zeros. And then it ANDs it. So it takes this mask and ANDs it with, let's say, an address. And so when it ANDs, if it's a 1 and a 1, it's a 1. If it's a 1 and anything else, it's a 0. So it ends up, we can talk about this more later. It figures out that this is the network part, looks in its routing table of where to send it. And in this situation, we're talking about IP4, 32 bits. We will talk about IP6 next week. Network discovery, 128 bits. This does an ARP. This does network discovery. Similar ideas. This is more efficient. The newer, the way it does it, a little more efficient, sends multicast instead of broadcast, and so forth. Talk more about that later. So in our case up here, we drew this up, we actually have like 3 networks. Actually 4, if you want to include this one heading out. Alright, I'm going to keep moving. So up here, we built this little scenario. We've got a router, and let's say for some reason we have these particular networks. So we're building a network out over here for some reason, maybe for whatever here. Then we have a network here. We said this network, 30 users. This would be less than 30, less than 30. But we have these 3 scenarios for networks. And there could be all kinds of reasoning. It's a little hard to understand right now, but there could be, you know, maybe this area here. Let me clarify that here a little bit. This area here could be all the students. Maybe this is all the faculty over here. Maybe these are servers or printers or something or whatever. So we need to take an address, and let's say we're given this address. Okay, we're given that address. Now we're using private addresses. Thursday we will do a public address example. Okay, so really it's a /24. We can't change this part. Okay, they said that's all. You got to leave that. So we can use this part. Okay, those 8 bits, which I've drawn out here. You can count these. There's 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now I put all those 1s in there. I'm going to take them back out. 2, 3, 4, 5, 6, 7, 8. Okay. So I'm going to keep going here. So we can split this up. Now we need at least 3 networks. So we can borrow bits. You know, we can draw a line. Now I did it in green here. And these bits here will represent the network, and these will represent the host. And you got to figure out where the line is. So you can actually do this by trying to say, okay, I need this many networks. Or you can look at this side here on the right and say I need this many hosts or interfaces. Now let's think about that for a second. So I selected the line right here. We often refer to that as you divide between the host and the network. The line was over here, right? Here's the network, and these were the hosts. But now I'm going to move it. I'm going to move it, cut this in parts so I can have more networks and just fewer hosts, because I don't need what would this be if we didn't subnet it. If we had 8 bits, a little reminder, I'll do it down here. 2, let me do it in another color. 2 to the 8th. That's 256 combinations. 0 would be the network. 255 would be the broadcast. So 1 through 255. No, sure. Yeah. So we'd have 254 combinations. Okay. So then here's what we did. I drew the line there. And I said this would be my first network, 0. That's this one right here, if those are all zeros. And now Here I have 2 to the 5th, which is 32. We can't use the network, we can't use the broadcast, so that's going to give us 30 addresses. Perfect, that's exactly what we need. Actually, we can put 29 devices in there because we have to use one of the addresses on the router, which would be the default gateway. Then we need some addresses over here and here. We'll have plenty because both of them were less than 30. So we can figure out the networks. Here's the first one. That's with all zeros here. Here's the first address. And 30 would be the last address. 33 would be the broadcast. Or, no, 31. Excuse me, 31 would be the broadcast, 32 is the next network, 33 is our first address, 62 is the last address, 63 would be the broadcast, 64 is the next network, 65 the next address. And how many could we make? Well, I'll show you. If this is 3 bits, that would give us 8. 2 to the 3rd. 2 times 2 is 4, times 2 is 8. More or less 8 combinations. So we could keep going here and make 8 of these. And then out of those 8, we would assign them. I don't remember exactly where I assigned what here, but you can take these and assign them to your networks however you want to do that. And there's some rhyme or reason how you do that we'll talk about later on. Subnetting. So, wrap it up. Finally, Mr. Dirksen. Okay. To wrap it up, you're working through the curriculum, which I say all the time. Okay. Make sure you do all the practice items. And then the lab, the first lab in our work, the first lab, you are supposed to have that done before class, actually, Tuesday night. It's due Tuesday night. That way I can look at them Wednesday morning and then we can work on that. And that lab is subnetting. Because we'd like to spend a little bit of time and get you in some groups to do some subnetting. And maybe get to the point where we can configure. We'll talk about that. And then variable length subnet mask. We will talk a little bit about that, but you can't talk about that until you can subnet. Okay? So hopefully we can get to that on Wednesday, otherwise we'll wrap it up on Monday. And IP version 6 next week. Fun. That's it.